Today's lesson is on trigonometric ratios. Our vocabulary today is trigonometric ratio, sine, cosine, and tangent. Using similarity, a right triangle with a given acute angle is similar to every other right triangle with the same acute angle measure. So triangle ABC is similar to DEF, which is similar to XYZ, and BC over AC equals EF over DF, which is equal to YZ over XZ. These are trigonometric ratios. A trigonometric ratio is a ratio of two sides of a right angle. The sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. So in our picture, the sine of angle A would be A over C. C is always the hypotenuse, and A is the side opposite angle A. The sine of B is B over C. The cosine of an angle is the ratio of the length of the leg adjacent to the angle to the length of the hypotenuse. So cosine of A is B over C, and cosine of B is A over C. The tangent is the length of the leg opposite the angle to the length of the leg adjacent to the angle. So tangent A is A over B, and tangent B is B over A. Make sure you have these memorized, and we're going to be using these a lot over the next few weeks. This is the basis of our entire unit for this unit here. In trigonometry, the letter of the vertex of the angle is often used to represent the measure of that angle. For example, the sine of A is written as sine A. Write the trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth of sine J. So the opposite side of J is 60, and the hypotenuse is 61. So the sine of the angle would be 60 over 61, which is approximately 0.98. The cosine of J is the adjacent side, which is 11, over the hypotenuse, which is 61. 11 over 61 is approximately 0.18. Remember, when we round a decimal, you want to use those two wavy lines for approximate. The tangent of K is equal to the opposite over the adjacent. So it would be 60, which is opposite, over 11, which is adjacent. So 11 over 60 is approximately 0.18. Use a special right triangle to write the cosine of 30 degrees as a fraction. So remember, we had our special right triangles 30, 60, 90, where we had a side was the short side, and then side radical 3, and then 2 times the other side. Remember, the cosine is adjacent over hypotenuse. So the cosine of 30 is s radical 3 over 2s. The s's cancel, leaving us with radical 3 over 2. Radical 3 over 2 is always the cosine of 30. And these are special angles that you'll need to memorize later on. We can also use special triangles to write the tangent of 45 as a fraction. Remember, tangent is opposite over adjacent, and tangent of 45 is s over s, which is equal to 1. Use your calculator to find the trigonometric ratio and round it to the nearest hundredth. Please be absolutely positive that your calculator is in degree mode, not radian mode, when you're doing these types of problems. First thing you want to do is push the sign button on your calculator. Then enter 52 and close the parentheses. When you press enter, you should get a decimal that looks like the one on the screen here. And so sine of 52 is approximately 0.79. If you do not get this value, you need to double check your calculator and make sure that it's in degree mode. Now try finding cosine of 19 using your calculator. You should get approximately 0.95. Now find your tangent button and try tangent of 65 degrees. The tangent of 65 degrees is approximately 2.14. The hypotenuse is always the longest side of a right triangle, so the denominator of a sine or cosine ratio always has to be larger than the numerator. Therefore, the sine and cosine of an acute angle are always positive numbers less than 1. Since the tangent of an acute angle is the ratio of the lengths of the legs, it can have any value greater than 0. Let's find this length and round it to the nearest hundredth. We want to find length of BC. BC is adjacent to the angle that's measured at 15. You're given AC, which is opposite of angle B. Since we have adjacent and opposite legs involved, we want to use a tangent ratio. So a tangent is equal to the opposite leg over the adjacent leg, which is AC over BC. We plug in 10.2 and 15 for our degree measure, multiply both sides by BC, and divide by tangent of 15 to get this expression. Go ahead and put 10.2 over tangent 15 in your calculator, and you get that BC is equal to approximately 38.07 feet. Be extremely careful that in trigonometric problems you do not round until the final step of your answer. If you round in between, you may end up being more off than you think. You want to use values of the trigonometric ratios provided by your calculator as much as possible. Let's try finding the length of QR in this example. We have an angle 63 degrees and the hypotenuse of our triangle is 12.9. We're trying to find the opposite side. So since we have opposite and hypotenuse, we use a sine ratio. The sine of P is equal to opposite over hypotenuse. The opposite side is QR and the hypotenuse is PR. Substituting our values, we get sine of 63 equals QR over 12.9. Multiplying both sides by 12.9, we get this expression. We put that in our calculator and get a result of QR equal to approximately 11.49 centimeters. Here's an example where we're finding FD. FD is the hypotenuse of the triangle, and 20 is the adjacent angle, or the adjacent side to 39 degrees. With adjacent and hypotenuse involved, we're going to go ahead and use a cosine ratio. The adjacent leg is EF, and the hypotenuse is FD. Substituting, we get cosine of 39 equals 20. Solve for FD, and you get the expression 20 over cosine of 39. Put that in your calculator, and you get approximately 25.74 meters for FD. Here's your lesson quiz. Go ahead and try some of these problems. See if you have any questions. Make sure you use your calculator and round anything that you need to. If you have any questions, please ask during class tomorrow, and we'll continue on with this with some applications and practice.